what we call a distance. So as far as we're concerned, we were talking about what? We were talking about the complex number. Do you still remember?
Yes.
We're talking about what we call a complex number. And we said, what is a complex number? We said a complex number is a real number. We said a complex number is a real number denoted. When you attend, please loop your mic, Mapula. It's a real number. We said a complex number is a real number denoted by Z, or is equals to A plus IB, where A is a real value and B is an imaginary number. So whereby A is represented by the real of Z and B is represented by the imaginary of Z. Are we still together? So
Yes.
again, we have said that when we are talking about the complex number, or let's say as an example, or we can solve using a quadratic equation, let's say in the form of ax squared or plus bx plus c is equals to 0. So when we solve for x using this quadratic equation, we know that our x is nothing but equals to minus b, or plus or minus the square root of what? Of b squared minus 4ac divided by what? By 2a. So indeed, we just did another example when we were solving this kind of equation, or plus 4 is equals to 0. So now, before we go there, we just tell you that indeed our I squared is nothing but equals to -1. So if we solve for I, it means we're going to do what? It means we're going to square root both sides. It means we're going to square root both sides. This is plus or minus. Then we find that indeed our I is nothing but equals to the square root of -1. We find. So that's why when we say simplify square root of -4, this is the same as square root of what? Of 4 multiplied by the square root of what? Of -1. Remember, this is a recap. We did this. This is the square root of 4 multiplied by, what is our square root of 4 is 2. What is our square root of -1 is our I. Are we still together?
Yes.
Okay. And again, we have covered many questions. As an example, we said that if you have got a question, remember we're doing a recap, we want to waste your time. If they say solve, we have got x squared plus 2x plus 5 is equals to 0. So ourselves, we know that when we're solving such kind of equation, when we're solving such kind of equation, we know ourselves that our x is nothing but equals to or minus b or plus or minus the square root of what? Of b squared minus 4ac or divided by 2a. Whereby when we substitute, we will have minus 2 plus or minus. We can plug these two on the brackets in the way that when we meet a negative, we must also put it in the bracket. 2 to the power 2 minus 4, our A is 1, our C is 5. Then divided by 2 into our A is 1. Then ourselves, we are going to press the calculator on everything that is inside the what? The square root. And we get nothing but negative 60. Then divided by what? 2 times 1 is 2. Then this is nothing but going to be equals to minus 2 plus or what? Or minus. What is this? This is the same as square root of 16 multiplied by what? Square root of minus 1 divided by what? Divided by 2. Then this is nothing but equals to minus 2 plus or minus square root of 16 is nothing but what? 4. Then square root of minus 1 is I. Then it means we have got this thing divided by what? By 2. So when we proceed with our things, you will see that indeed this 2 on the denominator is going to divide everything on the what? On the numerator. Are we fine?
Yes.
Then we get negative 1 plus or minus what? 2i. Do we have any question? And we have emphasized that if we have, let's say as an example, x squared minus 4 plus 4 is equals to 0, then we can use a quadratic or we can solve it like this. X squared is equals to what? Minus 4. Then in order for us to solve for x, we square both sides. When we square both sides, remember our square root goes with plus or minus. Then it means now we're going to be left with x is equals to what? Plus or minus. This is the same as square root of 4 multiplied by what? By square root of negative 1. And we know ourselves that indeed this is plus or minus 2. What is the square root of negative is I. Then we're done. Do you copy?
Yeah.
And again, we have covered such kind of equation whereby you were having something like, let's say I to the power of 3. This is the same as we said we first remove the first I, then multiply by, we write this as to the power 2. Why? Because ourselves, we know that I to the power 2 is equals to minus 1. Are we good?
Yeah.
So it simple means that this is the same as I multiplied by minus 1. Then we get negative I. And let's say as an example, we said I to the power, someone said let's try 25. So we said always we remove first I. So from 25, when we remove one I, what are we left with? 22. Are we good? We said this one, we write it as I multiplied by what? I to the power 2 close.
It's I to the power.
Well,
I to the 24. I to the power 24.
Oh, 24. Thank you. It's 24. I to the power of 24. So guys, we said when we multiply this, when we introduce, the moment we introduce I to the power 2 from this 24, it means we come here and we said 24 divided by 2. Then we get what?
12.
12. So 12 is our exponent. Are we still together?
Yes.
So this is I multiplied by what? negative 1 to the power 2. Then negative 1 to the power 12, negative 1 to the power 12 is positive. So we are left with positive times I, then we get this. Someone can say, okay, what about I to the power of 99? This is the same as what? We remove one I. Then we've got I multiplied by what? I to the power what? 98. Are we good?
Yeah.
Yes.
Then I said when we introduce that one, I to the power 2, we go to this 98 and we divide it by what? By 2,
By 2.
to get the what? The exponent. Then 98 divided by 2 is what?
49.
49. 49.
49. Then this is the same as I multiplied by negative 1 to the power 49. Then what do we get? Is it negative I?
Yeah.
Is there any question before I proceed? Hello?
No question.
Okay.
No.
So now, let's proceed. So let's talk about the addition and subtraction of a complex number. Addition and subtraction of complex number. When you attend, please loop your mic so that we may not hear your background. Or someone will come, you can find that others are attending on some people's room. Someone will come and say, baby, are you hungry? And while we're busy teaching, it's not good. Because we'll get tempted and say, yes, I'm hungry. So now, two complex number are added or subtracted by adding or subtracting the two real parts and the two imaginary parts. Let's say as an example, let's say we've got a Z1, which is nothing but going to be equal to or before we go there to our Z1, let's first play. Let's say we have A plus IB. Here we can either have plus or minus. We've got C plus ID. This is nothing but going to be equals to, we're going to add the real parts together. We said plus or minus, then not plus or minus. We said plus, now we add the what? the imaginary part together, b plus or minus b. Are we good? Okay, for you, in order for you to understand, let's say we have got a plus ib or multiply by, before we do multiplication, let's start by addition. If we skip, you won't understand. E.g., let's say we've got our z1. This is a complex. Let's say we have got our z1, or which is nothing but equals to, guys, hello?
Hi.
What is your favorite number?
Hello.
What is your favorite number? Okay, let me start by saying z1 is equals to a plus ib, and z2 is equals to c plus id. So then z1 plus z2 is nothing but going to be equals to a plus ib plus, can you please look your mic, plus c plus id. So whereby we are going to group those two is a plus c plus, this is I into b plus d. Did you understand?
Yes.
So can we proceed? Guys, please loop your mic, loop your mic, loop your mic, loop your mic. You will answer when you are asked a question. Because I can hear someone, I think it's making a lot of noise. So now, our z1 minus z2 is nothing but equals to a plus ib minus, I put a bracket, c plus id, whereby this one is like a plus ib minus c minus id. Then when we add the real by real is a, we're going to add a minus c, I will find, plus I into b minus b. I will start together.
Yes.
The first one minus the first one, the second one minus the second one. Can we proceed to the next slide? Hello?
Yes.
Okay. So now, let's say we've got our z1 is equals to 5 plus 4i, and the z2 is equals to 6 plus 2i. Let's say 3i. Even 2i is fine. So then, if we are finding z1 plus z2, is going to be equals to what? Hello?
It cannot be less than 5.
Sorry?
5.
5 plus 4i
6.
plus 6 plus 2i. Then which is equals to what? 5 plus 6 plus I into 4 plus 2. Then we get what? Are we good? Or you can write 6I, the same. Are we still together? Hello?
Yes, sir.
So now, as far as we are concerned, let's take this time and do you want us to do the one for subtraction or you are fine? Hello?
Yeah, fine.
You are fine, no?
Sipho.
Sorry? I
Yeah.
can't hear the person, sorry.
You do the one for subtraction.
Z1 minus Z2 is going to be equal to 5 plus 4I. Guys, the one for I is going to be subtracted with the one for I. The one for number only with the one for number only. That's all. Plus 2I. So therefore, this is the same as the number by the number plus I. Okay, let me just remove the brackets first. Why I confuse you? This is 5 plus 4I minus 6 minus 2I. So which is nothing but going to be equals to 5 plus, not 5 plus 5 minus 6. Number by number is like we're grouping the like terms. Plus I, we're taking I as a common factor. Then we've got 4 minus 2. Are we fine? This is minus 1 plus I2 or 2I. Is it difficult?
No.
Can we proceed?
Yes. Yes.
Okay. Now let's talk about what we call the augmented let's say arguments of the complex number. The arguments of the complex number. So when we're talking about the argument of a complex number, I don't think you guys have to go deep on the argument of a complex number, but when you are talking about the argument of a complex number, or this one, I think you guys must not go here. You will see it next year this way. But let's talk about the argument diagram. That one you will see it next year. Don't worry. Together we are. So now, let's say we've got Z1 is nothing but equals to S3 plus 2I. So remember, I have to go to technical high school and learn drawing. See that I'm failing. So ourselves, we know that this is the what? The real of Z, which is the X. Is that so? This is Y. Is the what? Imaginary of what? of Z. Are we good? Hello? Guys, why are you quiet? Maduva? Andani?
Hello, sir.
Why are you quiet? We are asking you, have to unlock your mic. Redwere?
We're still drawing and wait to unmute that so that we can talk.
Why are you guys quiet?
We are listening.
No, you must reply because it seems like I'm teaching people who are not existing. Ono vya mavidani abakwamba hete. Tongo ya mavidani na bankwamba note is it's really not good. Ngordo vusavo fao chendo. So now, as I was saying, you know how to draw. This is like the values of x and y. It's like a coordinate where x is represented by 3, where y is represented by what? By 2. Are we good? So we go to the x values, which is 3, and we connect it with the y values of 2. Then this point, it meets here. Then it means this is what? This is 2, not 2. This is 3 plus 2i. Is there any question? This is Z1 is equals to this. So let's say Z2 now. Let's say minus 1 plus 4i. Minus 1 is here. And 4 is here. So those things where they meet is here. I will find this is this one. There's no use to write those lines because myself I'm using a board here. Therefore, this is what? This is minus 1 plus 4i. Guys, is it difficult? Hello?
It is not specified.
It is not difficult, né? So can we proceed?
Yes,
Can we go to the next slide?
yes.
So now, let's talk about what we call multiplication and division of a complex number. Multiplication and division of complex number. It really shows that you guys are not practicing. I never hear someone asking me question saying, hey, I have stuck here. How do we do this? You guys, you are eating and sleeping. So now, remember that I squared is equals to what? Hello?
-1.
-1. Aizokutwa mbongara vafuni wenzana. -1.
Tired.
So now, let's say we've got A plus IB multiplied by C plus ID. This is equals to what? We're going to say A times C, we get what? Okay, let's say A. Our A is going to multiply this. If we're doing it in a primary way, then plus our IB is going to multiply this. Are we good?
Yes.
And this is nothing but AC plus IAD plus IBC
I
plus I squared
BB.
BD. But ourselves, we know that this guy is nothing but equals to -1. We're good. So we
Yes.
go with this, that guy, and we substitute what? -1. It means we've got AC plus IAD plus IBC minus 1 BD. But there's no use for us to put 1 minus BD. Then we group our things, real by reals, imaginary by imaginary. And plus, when we remove the common factor of I here, we get I into AD plus BC. Are we fine?
Yes.
So can we proceed?
Yes.
You can say since I squared is equals to -1 here after substitution to show that you are eating the course. Solve American Maragai. So now let's take another example. Let's say we have 2 plus 3i multiplied by 5 minus 4i. Then this is nothing but going to be equals to what? This 2 is going to multiply everything. And this plus 3i is going to multiply everything. Then when we remove the bracket, we're going to have what? 10 minus 8i plus 15i minus 12i squared. Is that so? This is 10 minus 8i plus, okay, we can even group the like terms. Minus 8i plus 15i, what do you get? Hello? Guys, can you see that? Can you see that those are the like terms?
Yes.
So minus 8i plus 15i, you get what?
Positive 7i.
Positive 7i. Then minus 12 into -1. Why are we saying that? Since we must tell them I squared is equal to -1. Then it's like we've got 10 minus plus 12 is what? We've got 22 plus 7i. Any question? Do we have any question? Guys, let's talk. Can we proceed? Guys, silent doesn't mean anything.
Okay, before we proceed, I wanted to ask something.
Yes.
I want to know when and how to use the argument diagram.
when you are asked to use it.
Okay.
Yes.
I'll have to like first solve whatever that they'll give me, and then after that I draw the diagram, right?
No, if they say draw a diagram, you have to draw it. If they didn't say draw, don't draw.
Okay.
Yes. But I don't know whether you guys you must go deep. If you are going deep, you will use your diagram when we are talking about. I don't think you will reach that stage. You don't go there, you guys, unless if we'll see. But I don't think you will draw it. But we'll see. Mara, I don't think so. You are still in foundation. And those things are introduced this year to you, because you are going to meet those things in mainstream. This is nice. Are we good?
Yes, thank you.
Okay. So now, as far as we're concerned, let's say now, I know you know how to here. Let's say you were given that not writing. Why it's not writing? Able. Okay. Let's say you were given that Z1 is equals to 2 plus 3i, and Z2 it was equals to 5 minus 4i, and they say find Z1 times Z2. So here is the solution. Are we fine? Where this is Z1 and where this is Z2, we just do what? We just substitute, then we remove the what? The brackets. Are we still together?
Yes, sir.
Yeah.
So now, let's say we have now Z1 is equals to 3 plus 2i, and Z2 is equals to 2 minus I. We say find Z1 divided by Z2. They say find Z1 divided by what? By Z2. So we're going to substitute. This is nothing but going to be equals to what? What is our Z1 is 3 plus 2i divided by what? Okay, let me just write it like this. This is nothing but going to be equals to 3 plus 2i divided by 2 minus I. Are we still together?
Yes.
Yes.
So we must multiply by the conjugate. And we didn't do conjugate, what's the hell? We must multiply by the conjugate of what? Of the denominator. Where would I add the conjugate? Everything is for B. Okay, well, guys, this is Z is equals to A plus IB. Then Z conjugate is equals to A minus IB. This is what we call the what? Conjugate. This is what we call the conjugate. Are we fine? We only change the sign for this. Are we still together?
Yes.
Yes.
Okay. So there we go. We're going to do what? We're going to multiply. We multiply by the conjugate of the denominator always. It means we're going to multiply by what? By 2 plus I divided by what? 2 plus I. Always we multiply by the conjugate of what? Of the denominator. Are we fine?
Yes.
Yeah, let's ask you.
If yapa pasiyari 2 plus I ndikotiyo kutimes nga 2 minus I. Ndikotiyo positive.
Yeah.
Ndikotiyo opposite na man. Tamba samba.
What were positive?
Oh.
Yeah. Those who didn't hear what she was saying, she was saying if, in fact, I will write it down so that I can explain well, you can see what I'm writing. She was saying if the question was 3 plus 2I divided by 2 minus plus I, what are we going to, how are we going to solve it? We were going to multiply by conjugate. It's just that now the sign, we only change the one for an imaginary number. Are we fine?
Yes.
Even if here it was negative, this is negative. We don't change the sign for a real. No, we only focus on the one for imaginary.
Okay.
You are sorted, ne?
Yeah.
Okay. So now this is nothing but going to be question. Here we don't cross multiply. We just say denominator by denominator, numerator by what? By numerator, whereby we're going to have 3 plus 2I multiplied by 2 plus I divided by, this is the same as 2 minus I multiplied by 2 plus I. If you still remember, this is the difference between 2 square. But by the way, this is nothing but 3 times 2. Or you want us to write all the steps, even those one for removing brackets? No. Do you know how to remove brackets, guys?
Yeah.
Yes.
Okay, 3 times 2 is 6, plus 3 times I is 3I, plus 2 times 2I times 2 is positive 4I. Therefore, 2I times I is positive 2I squared. Then divided by 2 times, this is the difference between 2 square, right? We say the first one times the first one, then the second one times the second one. Do you know that? Because the middle part is going to cancel. Or you want us to write it and cancel it? Yes, let's do it. Then this is 4 plus 2I minus 2I minus I squared. We're good now.
Yes.
Therefore, this one and this one cancel. Then ourselves, now we're going to be left with what? We're going to be left with 6 plus 7I plus 2 into negative 1 divided by 4 minus into minus 1. Since I squared is equals to 1. Are we fine? Since I squared is equals to minus 1. Then when we simplify, we're going to have what? Let me proceed at our right hand side. When we proceed, we are going to have this is equals to 6, not 6, but 6 minus 2 is 4 plus 7I divided by what? By 5. Are we fine?
Yes.
Then that denominator is going to divide each and every value which is on the numerator. Then we are left with a complex number. There we go. Is it difficult?
No.
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 Can we proceed?
Yes.
Yes.
Okay. Since you do understand, let me try to do this one first. Let's say we have 1 minus 3i divided by, let's say, minus 3 minus 4i. So how are we going to solve this? Can we do it fast? Do you mind? Hello?
No.
Okay. This is nothing but going to be equals to 1 minus 3i divided by minus 3 minus 4i, then multiply by the conjugate, minus 3 plus 4i divided by minus 3 plus 4i, whereby we're going to have nothing but 1 minus 3i multiplied by minus 3 plus 4i divided by minus 3 minus 4i multiplied by minus 3 plus 4i. Therefore, this is nothing but 1 times minus 3 is minus 3, 1 times 4i plus 4i, then minus 3 times minus 3 is minus 9i. Therefore, minus 3i times 4i is minus 12i squared. Then divided by, we remove the brackets, this is 9 or minus 12 minus 12, they cancel, guys. On the difference between two square, you just say the first one times the first one, the second one times the second one, then you are done. Are we fine? Do you copy?
Yes.
Sorry?
Yes.
Hello?
Negative multiply by negative is as positive.
Where are we?
Negative 9. I think it's positive.
Oh, this one is positive 9, right?
Yes.
Thank you. So guys, do you understand the one for difference between two squares? This one. That when we remove the brackets of this one, we just say the first one times the first one, the second one times the second one. Do you understand that?
Yes.
Okay, it means here now we are going to have negatives what? 16i squared. Are we good? Then this is the same as minus 3 plus 13i minus 12 into negative 1 divided by 9 minus 16 into minus 1. Since what? Since I squared is equals to minus 1. And when we group the like terms, minus 3 plus 12, what did you get? You get Nigeria, is that so? Then plus 18i divided by, then you say the Nigeria plus 16, then you get 25. Then this is nothing but equals to 9 over 25 plus 18 over 25i. Then this is your last answer. Is that so?
Yes.
Is there no question?
No.
Hello? No question. So let's do the last question for today before I teach this other class.
Okay.
Sorry?
Before
Hello?
the last question,
Yes.
before the last question, something.
Sorry?
Before the last question, I want to ask something.
About?
Agreement diagram.
Yeah, in fact, let's take this time as a question time. There we go.
Agreement diagram. Zero reflected the imaginary and the real. So this is a job plot and the research torado at the draw line and the Sukumala is the project line.
The line that's what was made the Rindigo plotters on and number like or are they corresponding?
No.
Yeah.
So their draw line is like yeah, Sara each open as a graphical and the plot as a research torado.
Where plotters or Sarazoto in the Zobana Zori like 2 is where and 3 is where are they meeting at the common point?
Okay.
No. Are you satisfied?
Yes, thank you.
So guys, let's say now you have you are given your Z1 as nothing but equals to 1 minus 3i, and Z2 is nothing but equals to minus 2 plus 5i, and they say find Z1 Z2 divided by Z1 plus Z2. So this is even nothing but going to be equals to substitute your Z1 is nothing but 1 minus 3i. Your Z2 is nothing but minus 2 plus 5i. Then you are going to be divided by your Z1 is 1 minus 3i plus your Z2 is minus 2 plus 5i. Are we fine? Then this is nothing but minus 1 plus 5i plus 6i minus 15i squared. Then divided by what? 1 minus 2 is minus 1, minus 3 plus 5 is positive 2i. Then when you remunerate the numerator, this is minus 1 plus 11i minus 15 into minus 1, then divided by 1 minus 1 plus 2i. Then when you simplify, this is nothing but what? 14 plus 11i divided by what? By minus 1 plus 2i. But you are not done because you must be left with something like z equals to a plus ib. Are we good?
Yes.
So this question takes us back where we multiply by the conjugate. Are we fine? Then we have what? We have minus 14 minus 28i minus 11i, then minus 22i. squared divided by 1 minus 4i squared. Are we fine?
Can I ask
Yes.
on the first step, where did you get -1?
Sorry?
On the first step,
On the
first step,
I can't hear you. The network is very poor.
on the first step, where did you get -1?
On the first step,
Yes.
oh, 1 minus 2.
Oh, not that one.
Sorry?
On the numerator.
On the numerator.
Yes.
You mean this? You mean here?
Yes.
Let me check. 1 times this one. Oh, it's -2. Sorry. It means the whole thing is wrong now. So why were you quiet all the time? You wait for us to finish. You see, guys, those things for not talking. Then here is what? Is -2. Is that so? Then we've got -2 plus 11i minus 15 into -1 divided by -1 plus 2i. And your time, guys, is up. I have to create another meeting for another class. Then this is what? Is it 13 plus 11i divided by -1 plus 2i. Then we multiply by the conjugate. Is that so? Are we still together?
Yes.
Then we get what? Minus 13 minus 26 I minus 11 I minus 22 I squared. And now we're saying numerator by numerator, denominator by denominator. And now we've got 1 minus 4 I squared. Are we fine? Can we finish this side? Then this is nothing but equals to, when you substitute y, let's just substitute -1 here and substitute -1 here. Then we're going to have what? We're going to have -13 plus 22. Is that so? Then we've got 9. Then we have got -26 minus 11. Then we've got negative 37i. And divided by what? By positive 5. Is that so? And this is 9 over 5 minus 37 over 5i. Any question? Hello?
No question.
Okay, thank you very much for your time. Thank you very much for your time.
Now I do have a question.
Yeah, you may ask your first.
It is still about the argument diagram.
Okay.
We
Sorry?
Okay. And now on the y-axis, you said, imagine that. Can you hear me?
Yeah, now I can hear you.
My question is about the argument diagram.
Yes.
Yeah, so I know you said on the y-axis is for the imaginary numbers.
You say why what?
The y-axis is for the imaginary numbers or the imaginary part of an equation. So I want to know, are we not supposed to write the, what do we call, the numbers in terms of I? Because yeah, are we not supposed to write, like if we are writing, we are, how can I put it? I know on the y-axis we just write 1, 2, 3, 4, 5, and then on the y-axis are we not supposed to write the number and then also include the I?
No.
We just write the number only.
Same way that I did here. The same way that I did here. We don't come here and say 2i, 4i. No, 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 no. Did you get it?
Can you explain again?
We don't come here on the x, on the y, and we say this is minus 1i. This is minus 2i. No, no, no. We don't do this.
My question is, are we not supposed to write if maybe we have z is equals to 3 minus 4i? Are we not supposed to write the 3 on, I get the 3 belongs to the x-axis, and then when we come to the y-axis, are we not supposed to write negative 4i?
Where? On the imaginary?
Yeah.
No. We write it when we are plotting it.
Oh.
Yeah.
Okay.
Okay, guys, thank you for your time. I'm really, really late. Those people are complaining. Goodbye.
Bye.